Tranquilo.
Hi, everyone. Welcome. I think we have some people already. Let's just wait a little bit to see if anyone joins. Maybe I'll start, and if some people came a little bit later, they will catch up with us soon, hopefully. So, first of all, hi, I already told you, but hi everyone, and welcome to Carver's webinar on industry digitalization with information in the driver's seat. I'm Anna, I'm from Landing.Jobs team, and I will be hosting today event. And I'm here with Paul Souza, Head of Engineering at Corber Digital. Okay, as we are waiting for some more people to join, I hope you are well seated and ready for the next hour. Are you hearing me properly? If so, can you please say it on the chat so that we can make sure everything is working fine and we won't have any troubles during the session? Thank you. For those who still don't know Corber Digital, as they like to put it, leverage the Corber manufacturing knowledge to build innovative products that aim to boost manufacturing efficiency. With this aim, they create and build software products to boost the digitalization of industrial production areas, either by partnering with other business areas of the corporate group or with external partners. If you have any questions throughout the session, please feel free to write them out in the Ask a Question button that you have in the bottom right of the crowdcast, and we will get to them in the end of the session. Okay. During the presentation, if feel free to leave comments, okay, in the chat, and we will keep an eye on it. If it's pertinent, we will get to that as well. Okay. For those who are joining just now, I'm Anna, and this is Paulo Souza, Head of Engineering from Cover Digital, and he is going to present us how they're contributing from their Porto offices to the digitalization of the industry all over the place and globally. Paulo, thank you so much for being here with us today, and the stage is yours.
Thank you. So I prepared the presentation for this day and for 1 hour. I will bore you to death during 1 hour. No, I'm joking. I'll prepare a simple presentation slides that will give you an idea of what's Corber in terms of organization, what's specifically Corber Digital, that is the area where I work, and what's our kind of mission and vision inside of the group. And then, because that will be kind of just a pitch from my side, then we'll go through more technical part where we're gonna address the different things that we do, the different learnings that we had through the last years, and how we get where we are at this point. So I'll say 50% of this will be more information and 50% will be tech topics where we'll go through different things, since storage, what storage do we have, what do we learn working with it, until I don't know, data ingestion or even backend technology. So I try to go through a bit of everything. So let me share my amazing slides, and you probably can see it. Yeah, I think so. Right. So let's start by going through what Corber is. I think I already give you quite a glimpse, but there's a few things that you don't know from Corber which make it quite unique, I would say, in the as a big company in the days that we in current days. So most of the current big companies with over 10,000 employees as we are are owned by stocks, are owned by people and by investors. We aren't. So when the founder started, he had a huge success, and someone along the way decided to use that money that he got to build a foundation. So Corber itself is owned by a foundation. This is Corber Foundation, and then there's the business that is a Corber Group. So the business obviously takes care of making money, and then we have the Corber Foundation that there's the other part is more the entrepreneurship that on the group. So the Corber Foundation has, I would say, two very interesting things. One of them is it's kind of a neutral party that sometimes is used to solve some conflicts in the European Union. And the other thing very interesting is that they have a prize that is the Corber Foundation Prize for Science, and that is given yearly. I don't know how much it is, 10,000, 100,000 euros, something like that, that is given to a scientist, to a project, or to a researcher that presented something that has added value to the society. And that is a funny prize because it's one of the best indicators of when will someone win the Nobel Prize, as most of the people that get this prize will then, in the next years, will drive their work to win a Nobel Prize. This is mostly the kind of structural thing with the foundation and the group. Then in the group, we have 5 things that are going on. From right to left, so tobacco was the initial area of the group. Here we have mostly machine building, so we sell machines that are able to produce tobacco. But we also have already a strong presence of digital products that are sold along the way with the machines. And we have tissue, so the ability to transform paper into different products. This again already a unit that has the iron, as we call it, that are the machines, but also the software part already. And we have supply chain with, you can imagine those fancy warehouses where everything is automated. We sell kind of a bunch of those equipments, and we actually sell full warehouses, and also great part already in terms of software applied here. And then finally we have pharma, that is not here in terms of producing pharmaceutical products, but actually packaging them and preparing their delivery. So in that case, we have actually an image of vaccines that are so present in our daily communication at this point. And then finally, we have digital. Digital was created kind of with a vision, and the vision is that in the next years, software will actually outsell the iron, so it will outsell the machines. And so that's the role that digital brings here. It's more I'll say, I don't like to use the term innovation, the innovation part of the company, but it's trying to drive the digitalization of the company and obviously the industry. And so let's dive a bit into digital, what we are doing, how we are doing, and also then technology. So, and I also said this, we are trying to co-create with our partners sustainable solutions so that help in increasing manufacturing or improving manufacturing. In terms of improvements we are looking, sustainability is one of the things. Also, efficiency is another. Digitalization is another vector to look at it. The Carbon Digital was created 4 years ago. Actually, not created; it was acquired. It was a company already existing in Germany, but it was acquired by the Corber Group. And then from there, we have been taking these steps. So when we here discuss our partners, it's mostly 2 kinds of partners at this point, and 2 kinds of way of working. Actually, not really kinds of partners, but 2 kinds of ways of working. One of the ways is actually pairing with the different companies. We have 20, 30, 40 different companies inside of the group. So pairing with those companies that don't have the technical expertise to develop software products. So they bring the business knowledge, they bring the kind of the product, and then we bring technology, we bring actually making it happen to the table. And as a team, then we build something. And the other thing is what I referred a bit as innovation. That is, so we have a process built in where we take ideas from the full group, from those 10,000 people that are in the group. We take those ideas, we go through a process through them. So we do a kind of an internal pitch for a startup, we do a proof of concept of it, we do an MVP, and then out of it, we actually create a startup. We call it ventures, but at the end of the day, it's a small startup, a small company that's trying to build their own product. These are some of the awards that we got this year in terms of IoT, in terms of innovation, and these two of them were specifically for one of the ventures that we launched last year. The other one was for the work that we are doing, some foundational work that we are doing to take information out of the machines. So then we have Portal, and I've been speaking a lot of different things. Where do Portal sits on this? So Portal, a few years back, so around 2019, the group was looking for a place to build a new center of excellence and was looking into different options. And one of the options was Porto. It ended up being the winner because of the talent that we have in Porto, because of the weather, because everyone likes to travel to Porto, obviously, and also because there's another company from the group already in Porto, so there will be kind of a nice synergy there. So we have an office in Porto currently. We have over 180 employees. These employees work in different areas. I will mainly focus on the digital part. On the digital part, we have Carver Digital as an entity, and then we have one of the ventures that is Factory Pulp. Then we have people working for pharma. They are working for manufacturing execution system that's actually the market leading. It's called Verum. The company is called Verum. We have supply chain people working for a warehouse management system. Again, that's from the USA. And we have IT solutions. We have kind of the IT branch of the group is also here in Porto. So let's start dive a bit deeper into technology topics and what are we actually doing. So we at Carver Digital, we actually do this, I would say, four main things at this point. One of them is IoT. So in IoT, we can look at the ability to gather information for what's happening in the shop floor and also send it to somewhere to be used. We then have kind of the digital twin, so the ability to represent something that is physical, like a machine, like a set of machines, like a company, like a set of companies also, but in a virtual way. This is a kind of an enabler for you to do configuration, for you to also do some kind of optimization, for you sometimes to test in a virtualized world what a change will bring for your production line. And then you don't need to do it in real life. You do it in a virtualized way. You check the impact, and then you are able to take an informed decision. Also, digitization, which is funny, but is also one similar meaning to digitalization, that is to transform a process that was otherwise done in paper, and we come facing dozens of those processes and try to make it digital. Just for numbers and for you to understand, at this point in Europe, we have around 2 million manufacturing companies. So 2 million companies that pick up a product and transform it in something else. And out of these companies, I'll tell you, 80 to 90% of it are small and medium companies. And the reality of those companies is that Excel is one of the most powerful tools that they use. And those are the good companies that are somewhat advanced. Some of them still use lots of paper. You can imagine that they have shifts going on, and they need to exchange information from one shift to the other, and they simply exchange paper. So there's a lot of stuff that can be improved there. And then optimization, because if everything is so manual at this point, nothing is measured, so you don't have numbers, you cannot optimize. And so these are kind of the four key things that we are trying to drive inside Carver Digital alongside our partners. Then let's go how we do that in terms of, let's say, organization. Inside Carver Digital is fairly simple. So we work with teams. So teams are kind of our unit of production, if we want. So usually a team here will have the usual setup of a cross-functional team. QA, front-end and back-end, supported by a product owner, also an agile coach, a team lead, and someone from UX UI. These teams then have the ability, and if they have necessity, to go through 3 different sets of teams. One team that's the architectural team, that usually helps on the start of the project or taking big decisions into a project. An operations team. Here we are looking more into a team that is able to support with tooling, who is able to support with knowledge on specific stuff like Terraform and CI/CD platforms and so on. And then we have a data science team also, is able to support any product or project that we are running with machine learning stuff, with also data science algorithms and so on. So let's look into our tech stack of it and to the things that we have been learning through the last years. And we don't have a fixed tech stack per se for all the projects. We have a set of common concerns that we try to take into every single project, into every single product that we build, but we end up by necessity or sometimes by constraints, we end up using different tools and technologies. Simple example, one of the projects that we are building is for one of the areas of the group that mostly uses C#. So as that area is also using C# and we wanted to reuse some of the code that they have, we then needed to go into C#. Another constraint may be, while we love to go cloud, there's specific things on the pharma side that need to be built to work on premise. So again, we would love to go cloud, but you have to build on premise. So that's also a constraint that we have to take into the project. But let's move along. I'll try to highlight any concerns that we take, so any kind of hard concern that we have when we're taking a decision. And if not, you can ask me more things at the end. So where do we place stuff? Mostly cloud. I'll tell you that probably at this point, 75% of our stuff is in Azure, 25% is in Amazon. We tend to go through managed services as a preferred option. Mostly because it takes most of the maintenance out of the way, and so it gives us flexibility to move forward. Also, we use Terraform pretty much everywhere. We started by doing a comparison between Terraform and IRM templates from Microsoft. At the end of the day, we chose to go with Terraform going forward. So that's what we are using currently for orchestrating our infrastructure. So then there's an important thing, right? The presentation was using data. Where does that data come from? Well, our data mostly comes from the actual shop floor. So this is a warehouse. It could be an assembly line. It could be a bunch of different things. And there's different machines here. So this is where we actually fetch our data. We fetch our data, if you look at this, from every single one of these machines, but also from what kind of objects are going into those machines, what kind of output is happening. Sometimes in the production, more in the production side, you have the humidity, so environmental factors. How's that in the factory? You have also the quality control at the end. So what's the purity of the product that we produce? How much residue do we have in the product? So those things are information points that we also gather. How do we do it? Well, honestly, it's not magic. It's actually something that we call a gateway. So some of these machines and most of these machines have sensors already installed. Many of them are produced by us, so by the group itself, so we know them quite well. We are able already to ship them with sensors, and we also are able to understand what most of the times their internal state has. So most of these machines have a PLC, that is a controller that has an internal state, well, mostly in binary, and we are able to hook up with something that we call a gateway. That is, you can imagine that is a Arduino with a SIM card. So a small computing unit that has the ability to broadcast communicate information that then is placed on the shop floor near one or more machines, and is able to go into those machines and read the data from their sensors, the data from their internal state, and then broadcast that information to somewhere. That somewhere is usually something on the cloud, either Azure or Amazon. At this point, mostly I think we're going into Azure. So there's an entry point there. That entry point simply receives is an endpoint, a very dumb endpoint, just as goes to pass through further information, that receives information and passes that information into a routing system. That routing system does message routing. So we treat everything as messages. You get a message, you look at that message, look from where it came from, kind of machine, the customer, and so on, and look at the subscribers that exist for information. And if it matches, it will pass through that consumer. In here, I would say that the main concerns that we had from day one was we need to ensure at least once delivery. So we need to really to ensure that every single message is delivered at least once for every single consumer. So we had to make sure that we have retry mechanisms in place. So if a failure happens, we need to retry it again. But also we need to ensure that we have some kind of backup mechanism. So we cannot be retrying to send a message every 1 second, because if a consumer is down, trying to send it to every 1 second probably won't help it coming up. And as that retry mechanism and that backoff mechanism usually is exponential, it will have to implement some kind of dead letter mechanism. So imagine like a storage where we will place every single message that we fail to deliver, and usually that will enable us to retry to send that message later manually or so, something like that. But also will enable us to be able to hook alerts into that system so that we can understand if something's going wrong. If we are starting to fail to deliver a message to a specific consumer, our message will end up on our dead letter mechanism, so we'll be able to figure that that specific system probably has a problem, and we can either alert the team that is working on that system, or we can take some corrective actions to mitigate it. Then, if we go through a bit further down the line, what will happen mostly is that our systems somewhere after receiving, so our products after receiving those messages, we go into kind of a streaming pattern where you have something like a Kafka or an Event Hub or a Kinesis hooked up that will receive that message, will gather it, and then will distribute to all the product event consumers. Those event consumers can do a bunch of different things, and we'll look into that in a second. So now let's dive then into that event consumers. So those event consumers usually do two important things. So they will extract information, they will transform that information and usually store, or sometimes they will just store that information. Those are the two main things that we do. Usually there we go through, just going back 1 second, usually here in our event consumers usually do two things at the same time. So that's one of the ideas why we want to have streaming here. So if we have most of the times we get state, we need to transform that into metrics. So that event consumer has to have business logic, and we'll end up writing the outcome of the computation that we will do into a database. But at the same time, we want to keep it. We want to keep the raw of that data. So eventually, we'll have that event stream also sent to a consumer that the sole job will be to store it somewhere into a cold storage like an S3 bucket or even a blob storage. And that will be our kind of our historical information that we can use also to reprocess anything that comes along. We need to rebuild something, if we need to we change the calculation and so on, we have also the raw information there. This is one of the things we try to have replayability along the way, but also one of those things that there's a common concern, but there's different implementations given the projects. So we have projects where we get actually metrics from on the messages. So it's easier, so that event consumer is mostly loading information, so he's doing ELT and not ETL. But there's also some projects where that event consumer it's quite business logic intensive, and because it gets states of machines, and then we have to store those states in some kind of cache or volatile persistence, so that we can then, after a few messages, be able to formalize what's the metric that we want to write, and then write up that information into the database. So we spoke about databases. For cold storage, I already told you, you're using blob storage or S3. No big concerns there, no big complaints also there. It works fine. In terms of storage documents, we started by using Azure Cosmos DB, and then we dropped it along the way due to performance issues, and we moved into Elasticsearch. And so far, we have been using for pretty much almost 1 year with very good results. And if you want to know more about why we did this change and what were the benefits that we saw and what took us in that way and how we used Elasticsearch, we can go through it in a second. Then, as most of the stuff we do is telemetry, is related with metrics. We are using Timescale. Timescale is a plugin over Postgres. We were using it because it also promised loads of benefits, but also after some trial and error, we figured there's actually no, at the scale that we were operating at this point and the number of customers that we are serving, we saw no advantage. It could happen if we had to scale this 10 times or 100 times, but that scale that we had, it was just added complexity, so we took it out and we just kept Postgres. Then on the magic part, here on the optimization, on the prediction side, we are working with supervised learning and unsupervised learning algorithms. So we have decision trees, we have linear regression, k-means clustering, those kind of things. Not by any means not an expert on this one. And then we are using to orchestrate most of these tasks, we are using Apache Airflow. It's usually, we are using it either running on Kubernetes or running into Spot instances, Spot containers, I think it's the right name now on Azure. Then obviously we get all the information into the database, we compute things, and then we need to serve this to present in an application, either web or also mobile. We have been using two ways, Azure Functions and also containerized applications. Containerized applications running mostly on either app instances, so as a single container instance, or in Kubernetes. There's pros and cons. Mostly on the Azure function side, we saw it's actually very simple to build and deploy. But then again, it's hard to test locally. You have far less control over your infrastructure, and you have less knowledge from the team. We have lots of learnings over operating this over the last 2 years. Stuff like you see, so a function itself has an app service that is where your request will end up, and then it has the function itself that will do to work over that request. But you will see the log of something coming. You see a request coming in, but you don't see a log of it coming into the app service. You also don't see it into the function. So there's kind of a black box there that we couldn't control or operate. So that was an issue. Also, it's a fairly new world if you are hiring in Portugal. So there's less knowledge also of how to operate this. And then we also find anti-patterns that people build into functions, but that's a story for another. Then Docker, again, it's a more Docker or any kind of containerization. It's a more simpler way because people are at ease with it, have more knowledge of it. It's easier also to test locally, to run in isolation, to run locally. Also to run in the pipeline for running some integration tests and so on. It's far simpler, but then again, brings a bit more on the effort on configuration and orchestration. So here we are trying to make very thought-through decisions of where to go, when to go to one, when to go to the other. Mostly we kind of have a template at this point that we use. That is, if it's C# related, we go with Azure Functions because they work quite well. If it's Java or Python that we are deploying on the backend side, we'll deploy it as a container. Mostly because we learned that there's a huge difference in behavior between the different languages because the app service itself is different. So when you run C# in an Azure function, you are running over a Windows environment, and it works very nicely. And then if you are running Java or Python, it typically runs over a Linux app service, and those are prone to errors. So we had an instance where we had a 24-hour outage of functions, and we had to move them into another availability zone because the Linux app services on that specific availability zone were broken due to an update. So we decided to move away a bit from it. And that's pretty much it in terms of backend. Relevant also to say that we, in backends, for authorization authentication, we mostly use Keycloak as an interface. So we place Keycloak in front of the identity provider. The identity provider would typically be either Cognito or AD-B2C, so Microsoft from Azure. And we then would place Keycloak in the middle because it brings already a lot of out-of-the-box management tools, but also because it enables us to serve as an interface. So if we need to change one of the identity providers because reasons, we can do it without actually needing to change anything on the application side. Again, just going a bit through the tech stack in terms of languages and also frameworks. We use Java, Python, and .NET. I would say that our main backend language are Java and .NET. Python, we are decreasing our number of lines of code, at least on the backend side. On the data science side, it's still the language to go to. On the front end, we took a decision to build everything in Vue. So all the products that we have at this point going on, and we have like 6 different products over 12 teams, they are built with Vue.js. We took the decision to invest in it. We built our boilerplate, so already to create a new project in Vue.js that comes along with our own. We have our own design system already built in for components, so we can reuse it there. We already have everything configured out of the box with the pipeline built, so it's fairly simple to start up a new application in Vue.js at this point. One interesting thing was this one. I think this is something that we learned along the way. That was in the Java side, to move away a bit from Spring Boot into Quarkus. And why do we do this? We did this because we saw that the metrics were better. And this is pretty much how we kind of take most of our decisions. So we try to find data that we can correlate and look at and make us take an informed decision of what we are doing. So in terms of Quarkus versus Spring Boot, we looked at 12 different data points. We looked at CPU usage, we looked at memory usage, thread usage, either underload or not underload. We also looked at garbage collection behaviors, and then we figured that Quarkus was the winner. Quarkus won in 10 of the 12 data points that we looked at. So it was faster to boot up, it used far less CPU, also had a better memory profile, so better memory usage. The only thing that it lost was in the terms of number of threads that he needed to use. So we, on that sense, Spring Boot used far less threads to underload than what Quarkus did, but we decided that wasn't the most important thing. Most important for us was actually CPU usage, and also even more important was the memory, as we handle lots of information on our services. Then we need to do a mention to testing, right? This is one of our key concerns, to automate everything. So across most of the teams, we use Postman with Newman for running backend tests, mostly end-to-end backend tests. Every single service that we build or function also needs to have unit tests. That's not even negotiable. So we build with unit tests, also a layer of integration tests and some end-to-end here. On the front end, we follow kind of the same pattern. We have unit tests. The definition of what's an integration test and on front end, it's a gray area, but we try to go there also. And finally, we go through end-to-end and snapshot tests using Cypress. Finally, because we are doing that for the physical machines, for the iron, we also need to do that for what we deploy. We are working at this point mostly with Grafana to show our metrics. We use Prometheus and the alert manager that comes with it to run loads of our alerting out of it. And we also use Azure Monitor, because if we want to do something like with functions, it's far more simple to actually build into Azure Monitor the alerts and the dashboards that you need than actually to export the stuff into Grafana or Prometheus, in Prometheus actually. Finally, this is one of the things that we try to embrace through this journey. That is to build communities. So we run the communities on backend, on front end, on QA, also on data science. We run them on in Corba Digital, also open to the outside, so open to any company on the group that wants to participate. And there we try to share what we learned. So that if a team understands that using Quarkus is better because of their conclusion, we can share with the others, we can have an open conversation about it, and we then adopt it as the way we go forward. And also to embrace this try, repeat, fail, and learn method where we will try things, we'll compare RM templates with Terraform, and then we'll figure what's the best thing out of it, we'll learn, and then we'll go into the next experiment and try to learn from there. And that's it mostly from my side. So if you got any questions, I'm back. I can see you now.
Thank you so much, Paulo. It was a great presentation. We are going straight to the questions. If you still didn't put out the question, please feel free to, or any curiosity that you have on Corber or about Paulo's job or anything that you would like to ask. I think I'm saying, but I think you can ask that. And let's start with this one question that we have here. What exciting projects do you have on your development pipeline at the moment?
Okay. Okay. At this point, we are working with. There's a part of information. So just disclaimer, very simple disclaimer. There's a part of information I can disclose and a part I cannot. So I'll go through what I can disclose. There's one of the interesting ventures that we can is Factory Pal, as I mentioned in the presentation. I think there's a very, very exciting project that's looking more into the optimization of processes on the tissue side, so on the production of toilet paper, for example. But that's looking into velocity of machines, throughput, and then final product, and how can we optimize that. That's one interesting. There's one very interesting that is still in stealth mode. I think it will be started by somewhere early next year. That is using image recognition to detect failure patterns in medical supplies. So that's something that's very interesting. Then we have a gamification going on, a gamification initiative at this point. That's mostly to look at how can we use gamification and learning to improve knowledge of shop floor operators. If you look at some of the industries that we act, for example, if you think on machine operators, in Germany, for example, we have a great percentage of them that will retire the next year. So there's a lot of knowledge that will be lost. And so we were looking at how can we use gamification and some learning so that we can kind of spread that knowledge. If that will work, we'll see. Those are the next steps. Those are kind of the, I think, three most interesting ones.
Okay, thank you. Next one. Regarding career development, which path do you have in corporate?
That's a very rough question. Okay. I can go through what we usually do. And then if you have a follow-up, let me see who asked that. If I have a follow-up, Joanna, I'm happy to take it. But so usually what we'll do for every single person, so we have written competency profiles for every single job spec that we have with the different levels. You can be junior to senior. And then we do some very close development with people. I was trying to say accompanying, but I couldn't find the English word for it. So we do very close development, meaning that we have a team lead in every single team that is responsible for growing the people. So that's one of the things that we actually take care of. That is, we will eventually lose the people. That's the market. So people will join us, but will eventually leave. But the only thing that we want is that two things happen during this journey. But at the point that they leave, they look back and they are able to see that I'm better now. So I'm a better professional now. I have more competencies that I had when I joined. And at the same time, from our side, that while you do that journey, we also contribute to the company. So those are the two things that we look. So we try to have those goals set per quarter. Those goals need to be also aligned with your career expectations, where you want to develop. And then we try to be very open in terms of possibilities. Imagine for senior roles, do you want to go into a senior role, keep doing this, go into architectural, go into a principal role, or you want to switch into a managerial side? Okay. And from UI, I cannot speak too much of the UI part. I only manage engineering, but I would say it's pretty much the same thing. So very close with the people, training, always a training plan for every single year with objectives and what you want to have, and very honest and transparent feedback. That's all.
Great. Picking up on the job parts, let's remind the people who are watching us that Corber is hiring, and they have the jobs posted at Landing.Jobs, so you can check that out and see if you are interested in applying for them. You have also a button here in a green tone that you can click and go ahead and check those jobs. And on that topic, we have another question that is possible to work remotely, or there's a need to relocate to Porto?
There's no need to relocate to Porto, but at this point, for Corber Digital specifically, we are hiring just in Portugal. There's inside of as I told you, inside of what's Corber Digital in Porto, there's 4 different places. The rules change a bit depending on the place that you apply to. I can speak for Corber Digital. At this point, what we are looking is to have kind of a touch point once per month, so that the person should go to the office once per month to have a touch point with the team, to go for lunch, to have a retrospective, and so on. Having said that, we are completely remote at this point. We were created in March last year. We never gone to the office. I don't think I know everyone that I hired, and it's working. But I think that touch point monthly with the team, I think it will be very interesting, and just to have some team building going on. That's our idea for the future.
Okay, great. One more question. What are the main challenges for creating digital twins at scale?
Thank you, Clement, for the question. So our main issue at this point, it depends a bit on what you mean by scale. If you are meaning with having many customers of a given industry, or having many customers of different industries, I would say that the two main challenges would be the lack of standards for the moment. So there's a complete lack of standards. We can go even from the IoT side. So depending on the supplier of the machine, the information will come in a different way. And if you have a new supplier, you have to figure out how that's going. Because it's interesting for us to have a digital twin, but also to be able to connect with machines, so to be able to see the status, to be able to see information of the machine, and so on. So you need to be able to communicate with the machine, to read at least information that is supplying. And that usually is a headache, because you need to figure what's there. And the other thing is actually the difference between industries. And that's one of the, so I was in that innovation process last week, and that was one of the issues that we were thinking a bit, is that if you look at there's something called MES, that is a manufacturing execution system. If you look at the landscape, you see that there are a lot of players, there's a lot of companies doing it. But you also look that they are all pretty much all niche players. So every single one of them is only addressing one specific industry, one specific part of an industry. And that's because there's such a difference between the industries that it creates such complexity to build something that we're able to scale through every single industry. If you have a solution, let's discuss it, because I really would like to hear it.
Great. One more question. I don't know if anybody has any more. Please write it down. Or this is our last one. What can someone expect when joining Cover?
Another broad question. I love broad questions. So, what can someone expect? Well, it's a journey. So it's not everything. Not everything is built at this point. We are far from it. We are still building a lot of stuff. We will have a lot of challenges. The industry, we are working for the industries, for manufacturing. As I told you, a very heterogeneous landscape. So that creates a lot of challenges. and learning. I think that's been kind of the most interesting part so far. We are able to touch not all of the subjects that I told you. Uh, yeah, I was really sorry. I was reading comment. Your comments. Yeah, true. So and that constant learning, I think that's one of the most interesting things that we have been able to build is this culture of learning, of being able to do something, taking our own options as a team, obviously inside of a set of safeguards that we place, but being able to go as a team into a direction, learn from it, and share with others. I think it's one of the nice things we can offer.
Great. Thank you so much. Thank you, Paul, for your presentation. Thank you, everyone who is with us and for participating with questions and on the chat. I hope to see you soon on another webinar and have a nice day. Thank you so much.
Thank you. Bye.